Good morning, everyone. My name is Lim Ding Jian. My student ID is 210366918. Today, I'll be presenting my NBA player performance dashboard, a project designed to provide actionable insights for front office decision making in the NBA. This dashboard is focused on analyzing player performance, career progression, and efficiency trends using data visualization and business analytics techniques. Unlike a typical report, this dashboard is fully interactive, allowing users to explore the data dynamically. Front office personnel, such as scouts, analysts, and general managers, can use it to make informed decisions on player scouting, drafting, and contract management. Over the next 12 to 15 minutes, I will guide you through the objective of the project, the design process, the challenges I faced, and the solution I implemented, a live demonstration of the dashboard, and finally, the key insights and recommendations that emerged from this analysis. The main objectives of this project is to focus on understanding NBA player performance from multiple perspectives and making that information actionable for front office decision making. First, we aim to visualize the relationship between player physical attributes such as height and weight and key performance metrics, including points, rebounds, and assists. By doing this, we can evaluate whether taller or heavier player automatically perform better or if skill, role, and agility play a bigger part in a player's success on the court. Second, the project seeks to compare player performance across different draft rounds and college backgrounds. This allows us to assess the value of draft investment, identify overlooked talent, and understand which college consistently produce top performing NBA players. This insight can help teams expand their scouting beyond the traditional powerhouses. Finally, the dashboard is designed to track changes in player efficiency and playing style over multiple NBA seasons. By examining trends in net rating and advanced metrics, we can observe how player roles evolve, how performance changes with age, and how external factors such as changes in league style or unusual seasons like the COVID-19 bubble in fact impact efficiency. Together, these objectives ensure that the dashboard is not just a set of visualization but a tool to provide clear, actionable insights to support scouting, drafting, and contract decision. For this project, I sourced data from Kaggle, which provides a comprehensive NBA player stats dataset covering the seasons from 1963 to 2022. This dataset includes 12,844 players' season entries, which far exceeds the minimum requirement of 2,000 records for this assignment. The dataset contains multiple categorical dimensions such as player name, team, college draft year, and draft round, as well as numerical measures including point per game, rebound, assist, net rating, true shooting percentage, and assist percentage. The richness and reliability of this dataset made it ideal for sports analytics. It allows for detailed analysis across eras, draft classes, and colleges, while also enabling more advanced efficiency comparisons. For example, using net rating and usage percentage, we can evaluate how players contribute to their teams beyond just points scored. Using this dataset ensures that our insights are statistically meaningful and grounded in real historical NBA performance, making them relevant and actionable for decision makers. In designing the dashboard, I focus on making it both functional and intuitive for the end user. One of the first decisions was selecting appropriate chart types. Bar charts were used for average comparison as they are the clearest way to show differences between groups, such as points scored by player of different heights, and pie charts were used to show proportional data like draft round distribution, which allow the user to quickly understand the composition of the league in terms of draft investment. The layout was designed to mimic the workflow of front office personnel. Filters were placed at the top of the dashboard to allow quick access, and the charts follow a left to right order, beginning with physical attributes, then college, draft status, efficiency, and ending with age. This mirrors how scouts and analysts typically evaluate players. I also focus heavily on user experience. The dashboard requires minimal clicks to access insight, support cross-filtering between charts for connected analysis, and maintains mobile-friendly spacing to ensure usability on tablets. Finally, I leverage Python and Pandas in Google Colab for data cleaning and preparation, while Tableau was used to build the interactive and visually appealing dashboard. By carefully considering these design elements, the dashboard is both effective and user-friendly. The design choices were made to maximize clarity and efficiency. Bar charts were chosen for comparing averages because they allow scouts to see difference across group at a glance. For example, average points by height category. Pie charts were chosen for showing proportions, such as the breakdown of player by graph round, because this type of visualization is immediately understandable and visually clear. Color consistency was another key design choice. For instance, first round draft picks are always represented in blue, second round in yellow, and undrafted player in red. This consistency helped users recognize patterns quickly without needing to refer back to a legend constantly. Filters were positioned at the top of the dashboard to give the user immediate access so they can select a season or draft status without scrolling or searching. Finally, the left to right layout follows the natural workflow of scouting and player evaluation, making it initiative for users to move through the data from physical traits to college performance to draft analysis, efficiency metrics, and finally, age related performance. Each of these decisions ensures that the dashboard is not only visually appealing but also functionally aligned with front office needs. While building this dashboard, I encountered several challenges. One technical difficulty was that the filter layout in Tableau initially broke when multiple filters were added. To solve this, I used floating layouts and manually align all the filter components, which ensure proper functionality across all visualizations. On the data side, missing values for college represented a challenge. There were 1,854 missing entries, many representing international players or early era athletes. I choose to label this as no college, while undrafted players were retained as NAN values, which allowed for meaningful analysis of draft performance. The initial scatter plot I created for height versus point was too cluttered to extract meaningful insights. By converting it into a bar chart grouped by height category, the visualization become much clearer and more interpretable for the end user. Finally, finding and validating NBA player data was relatively easy for me as an NBA fan, which allowed me to quickly cross-check stats for accuracy. I also tested the dashboard on tablets to ensure proper spacing and interactivity so that the final product is usable on multiple devices. This solution made the dashboard robust and user-friendly. Data preprocessing was a critical step before visualization. I began by removing unnecessary columns, including default index fields. Data types were standardized, converting the season field into a string so Tableau could treat it as a categorical, and converting draft number to float for numerical calculation. I also checked for duplicate rows, which returned 0, confirming data integrity. Missing college value were labeled as no college, while undrafted players were retained as NAN values to allow fair comparison of drafted versus undrafted players. Finally, the clean dataset was exported as NBA data clean CSV for use in Tableau. These preprocessing steps ensure the accuracy of calculated fields and aggregation, allowing the dashboard to function reliably while delivering trustworthy insights to front office personnel. The dashboard brings together five main visualizations into a single, cohesive view. The first visualization shows height versus points, rebounds, and assists, allowing us to see how physical traits relate to performance. The second compares averages points by college, highlighting which programs produce high scoring players. The third examines performance by draft status, showing the relative impact of first round, second round, and undrafted players. The fourth visualization tracks efficiency trends over multiple seasons using net rating, which allows efficiency rating, which allows teams to evaluate performance consistency and contextualize unusual seasons, such as the COVID-19 shortened season. The final visualization shows the peak scoring age of players, providing insights into optimal time to invest in contracts. By combining all of these visualization, the dashboard provides a holistic view of player performance and allows scouts and analysts to identify patterns and make informed decisions without needing to use multiple tools. So let me do a quick live demonstration. So this is the four interactive feature of this dashboard. Each one is designed to answer a specific type of question by controlling a particular visualization. So I'm going to walk through these four: season, team abbreviation, although it's not very clear here. The third one is select metric. Fourth one is draft status. So season is directly connected to average points per head category. So for example, if I want to see 98, 99 season, I can press this. For example, tall players score the least, short players score the most, and the medium players score medium. And if I want to see 08 to 09, yeah, so it changes every time if I want to see how well that season performed. Okay, so I'm going to talk about team abbreviation here. It is directly connected to peak scoring age. So, for example, if I want to check the peak scoring age for Boston Celtics, it's 35, and for Los Angeles Lakers, it's 30, and for New York Knicks, it's 30. So this is basically it, and I'm going to talk about select metric now. This is directly connected to average points by height category 2. So you can see if I'm selecting points, it shows like this. Is if I'm selecting rebound, it shows like this. Obviously the tallest get the most rebound, and assists, the shortest as point guard get the most assists, obviously. So I'm going to talk about draft status now. For example, if I click all of this, it's going to be blank. If I press first round, it's going to show me that 10.6 10.16 for first round. Second round 6.2, undrafted 4.7. And it's also aligned with our report, which is we said that first round is going to perform the best always, and after undrafted is going to be the worst. So each interactive element here serves a dedicated purpose. Rather than filtering the entire dashboard, they allow the user to focus on one key relationship at a time. For example, season vs trend, team vs age, metric vs height, and draft status vs performance. This design lets an analyst quickly flip between these four important questions without overwhelming the view with too many cross filters. Several insights emerge from the analysis. First, shorter player under 190 centimeters tend to score slightly more on average, demonstrating that skill, agility, and offensive role are more often important than height. Examples include players like Michael Jordan, Kobe Bryant, and Stephen Curry, who achieve elite scoring despite being shorter than many of their peers. Second, Wake Forest produces the highest scoring players on average, even outperforming traditional strong programs like Duke and Kentucky. This suggests that teams should expand scouting beyond the well-known powerhouses to identify talent in less traditional pipelines. Finally, players typically reach their scoring peak at age of 27. This insight allows front office to align contract offers with player prime years, maximizing performance and minimizing financial risk. This insight collectively provide actionable guidance for scouting, drafting, and contract planning decisions. This project taught me several important lessons. First, clean and well structured data is the foundation of any meaningful analysis. Even minor inconsistency can distort insights and mislead decision makers. Second, interactivity increases the adoption of dashboard. Front office personnel are more likely to use a tool that allows them to explore data dynamically and ask their own questions rather than relying on static reports. Finally, domain specific design builds credibility and trust. By designing visualization that align with the workflow and priorities of MBA analysts, the dashboard is immediately relevant and actionable, which encourages its use in real-world decision-making scenarios. In future iterations, the dashboard could be enhanced in several ways. Integrating player salary data would allow analysis of value for money, helping front officers evaluate whether performance justifies costs. Real-time stats integration through APIs would ensure the dashboard reflects the latest game and performance, keeping insights current. Additionally, adding predictive aging curve would allow teams to forecast performance beyond a player's prime years, supporting more strategic contract planning and long-term roster management. This enhancement would make the dashboard an even more powerful tool for NBA decision makers. Finally, the sources used for this project include Foxpot and five of these at the screen. And these references ensure that the data, context, and example used in the dashboard are credible and accurate, supporting both and the analytical process and the conclusion drawn. This completes my presentation of the NBA player performance dashboard. Thank you for your attention, and I look forward to any question or feedback you may have. Thank you.